Alright, today we're going to look at how to simplify radicals. This is chapter 4, topic 9. Simplifying radicals is required for some problems we're going to have to do with quadratics. So let's take a look. First, you probably know how to simplify the square root of 4. Square root of 4 is, of course, 2. But let's look at why the square root of 4 is 2. So the way the square root works is that there's a fake number here called the index. And what this index means is that if you can find, the index tells you how many pairs you need, or how many of a kind you need. So when we're looking at the square root of 4, we want to know the factors of 4. And if we can find any two of a kind factors, we can bring them outside the radical. So if you think about 4, and we use a factor tree, then 4 is 2 times 2. So we can rewrite the square root of 4 as 2 times 2. Well, the index, being 2, tells us that we need two of a kind of the same number to take out of the radical. So we have two 2's here, which means those two 2's can come on the outside and create one 2. Alright, a pair on the inside creates one on the outside. So those would go away and there'd be nothing left on the inside, and what's on the outside would be 2. So the square root of 4 is equal to 2. Same thing with a problem like number 2, which we have the square root of 121. If we break up 121 into its factors, we see that it's 11 times 11. So the square root of 21 is really the square root of 11 times 11. Well, the index of 2, and a square root always has an index of 2, it tells me that I need two of the same number, I need two of the same factor under the radical to make one of those numbers outside the radical. So that means that the square root of 121 is 11, because there's two 11's under the radical, which makes one 11 outside the radical. So the square root of 121 is 11. What about the square root of 32? Let's break down 32. And we can break down 32 into a couple of things. We can break it down into 2 times 16, and then 16 can break down into 4 times 4, or let's try something else. Let's do 2 times 8. And 8 can break down into 2 times 4, and 4 breaks down into 2 times 2. So 32 would be 2 times 2 times 2 times 2 times 2. It would be 1, 2, 3, 4, 5 2's. Now what I know is that for every pair of 2's on the inside, I can bring a single 2 to the outside. So here's a pair of 2's. That means I can bring those pair to the outside. So that gives me 2 and 3 2's on the inside. But I can still bring another pair out, because there's another pair right here that I can bring out as well. So I have 2 times 2 on the outside, which is 4, and on the inside, I only have a single 2. So the square root of 13 reduces to 4 square root of 2. What about the square root of 24? Let's break down 24 into all of its factors. 2 times 12, and 12 is 3 times 4, and 4 is 2 times 2. So the square root of 24 can be written as 2 times 3 times 2 times 2. Alright, so we're looking for pairs. because a pair on the inside makes one of those numbers on the outside. So right here is a pair, so that'll make, that pair of 2's will make a single 2 on the outside. So we got 2 square root of 2 times 3. That's the only pair that's on the inside. So this means that the square root of 24 is 2 square root of 6, because we just multiply these back together to give us 6. So the square root of 24 is 2 square root 6. Now, what about if you have a numerator and a denominator, like a fraction, and you're taking the square root? Well, that's easy enough. We just need to do them separately. We need to do the numerator and denominator separately. So first, let me figure out what the square root of 8 is. So 8 breaks into 2 times 4, and 4 is 2 times 2. So this is 2 times 2 times 2. So a pair of 2 on the inside will make a single 2 on the outside. So I have these two make a 2 on the outside, and I still have a 2 on the inside. So the square root of 8 is 2 square root 2. I'm going to do the same thing for square root of 9. Well, 9 is just 3 times 3. So this is square root 3 times 3. Well, a pair of 3 on the inside will make a single 3 on the outside, and I won't have anything left. So the square root of 9 is 3. So the square root of 8 over the square root of 9 is 2 root 2 over 3. Square root of 44. So 44 breaks down into 2 times 22. 22 breaks down into 2 times 11. So the square root of 44 can be written as square root of 2 times 2 times 11. A pair of 2's on the inside will make a 2 on the outside. So we have 2 on the outside, 11 on the inside. So square root of 44 reduces to 2 square root 11. What about if there's already a number on the outside? Like -3 is on the outside. That's okay. Whatever we bring out to the outside, we just multiply by -3. So 98 breaks down into 2 times 49. And 49 is 7 times 7. So square root of 98 can be written as 2 times 7 times 7. Well, 2 7's on the outside will make 1 7 on the 2 7's on the inside will make 1 7 on the outside. So square root of 98 is 7 square root of 2. So that 7 that's coming to the outside is now going to get multiplied by this 3. So what this becomes is -3 times 7 square root of 2, which is just -21 square root of 2. So -3 square root of 98 becomes -21 square root of 2. That would be the simplified form. Another fraction, so we'll do the numerator and denominator separately. So 12 is 3 times 4, and 4 is 2 times 2. So square root of 12 is the same thing as 3 times 2 times 2. 2 2's on the inside make a 2 on the outside, and we're left with the 3 on the inside. So square root of 12 is 2 square root 3. We'll do the same thing with 625. So 625 breaks down into, let's see, I know for a fact that 5 goes into it. So 5 times 125. 125 is 5 times 25. 25 is 5 times 5. So 625 breaks down into 4 5s. Breaks down into 5 times 5 times 5 times 5. Which means that we can take two pairs of 5s out. This pair of 5 and this pair of 5. So on the outside becomes 5 times 5, because 1 5 times 2 5. So that's just 25, and there's nothing on the inside. So the square root of 625 is just 25. So square root 12 over square root 625 is 2 square root 3 over 25. Alright, so the homework for this, we have a worksheet for simplifying square roots. Please show your work for these problems.